We've gotten everything set up from our tutorial to get you set up making modifications to create your own game from it. In this video, we are going to talk about code to try and make you more comfortable if you are unfamiliar with programming. If you already know a little bit about programming, this video is still going to be useful to you because it will show you how to open and edit scripts in Unity. This video will also introduce you to the format that code for these tutorials was written in. Back in Unity, if we look at our project folder window, we can see that we have a scripts folder. This folder is organized with subfolders that organize various scripts based on what they do. For example, the camera scripts are in the camera folder, and scripts controlling the enemies are in the enemies folder. The scripts in these projects range from very simple to highly complex, with the most complex usually being the scripts that handle management, enemy AI, the player, and the camera. The simplest script, and the one we are going to look at in this video, is the projectile script, located under Scripts, Shooting Projectiles. To open a script in Unity, we can right-click and select Open C# Project. This will open your entire C# project, which includes your assets folder and all of your files from your Unity project within it. To get to our projectile script, we just need to follow our folder structure the same way we did before. Scripts, Shooting Projectiles, Projectile, and we can double-click it to open it. If you are fortunate enough to be running a stable version of Unity, you should be able to get to the same spot by going to Unity and double-clicking your scripts directly in your project folder. The version of Unity this video was recorded on has a bug where scripts lose their project association when opened that way, so opening the C# project is the method we are showing. Once you have the projectile script opened, we can walk through it together to get a basic understanding of everything in the code and the way Visual Studio presents the code to us visually. One of the first things you'll notice is that there are a lot of different colors on the text. You might also notice that on your screen you probably have a white background, which is the default, where mine is this sepia tone. You do not need to worry about the background color. The background color is just a setting I changed for myself because I spend a lot of time looking at code in Visual Studios, and I found that this is much easier on my eyes. If you want the same color settings, we'll have a video explaining how to get that set up separately. The color coding on the text is meaningful and should be the same for you as it is for me, with the exception of function names, where the default is black but mine is this brown color. The reason there is this color coding is because Visual Studio is an IDE, or an Integrated Development Environment, which is a text editor with extra tools to help you write code. In Visual Studio, there is color coding and IntelliSense, which we'll get into later when we actually write code. For now, let's walk through this line by line. On the left, you will notice line numbers starting at 1. When you run into errors, you will usually get line numbers telling you where in code that error happened, so you know where to look. On the first 3 lines of this script, we have what are called using statements. These are basically saying that this script uses code from these other groups of code. You might notice that the first 2 lines are grayed out. That means that these using statements are extra because the IDE has detected that none of their code is being used elsewhere in the script. The next lines of interest are lines 5 through 7. This is a special type of comment called a summary block. What the summary block does is make it so that if you were to use this class underneath the block somewhere else in code, you can mouse over it to read the summary. For example, if I mouse over projectile, I can read the same summary we see above it. The point of this specific summary block is to be a class header, which is a header that briefly describes the class beneath it to tell you what that class is supposed to do or handle. All of the scripts we provide you should have these headers to help you with understanding the code and how it was set up, but the headers don't do anything for making the game actually run. On line 8, we have a class. We'll go into the details of how to create and use a class later, as well as what everything on this line means. On line 10, we have a tooltip attribute, which is text that will show up in the inspector window when the variable below it is moused over. So if we go back to our Unity, then we look in our prefabs, projectiles, player projectile, and then select the player projectile and find the projectile component, we can mouse over the projectile speed label. And we can see that it displays some descriptive text about what the setting does, which is the same text we have set in the script for the tooltip. Every variable that we have showing in the inspector should have one of these tooltips. So if you want to know more about what a setting does, you just need to put your mouse over its label. Back in our script, you can look at line 11 and see that same setting projectile speed is present in our script. You might notice that the name in the inspector displays differently than it does here, and that is because Unity automatically makes these names look nice in the inspector, whereas in code we follow a naming convention, which we will get into later, that has us writing variables in this style. All you need to know for now is that those settings values you are changing in the inspector are also actual variables in these scripts. The next lines 13 to 20 are another summary block, another comment that doesn't functionally do anything but does make the code easier to read. More specifically, this is a function header. It provides a brief description of the function below it, where a function is a block of code that can be run to do whatever it is the function is set up to do. All of the functions in our scripts have these function headers. So if you're reading through the code, you can read through these headers to get a description of the function, as well as its inputs and its return values. Line 21 is the start of the actual function. The first word, private, means the function can only be used within the class it is in. By default, functions and classes are private, so this word could be deleted. The second word, void, is the return type of the function. In this case, it is void, which means the function does not return any value. And the third word is the name of the function. This particular function is special, which is why it's blue and not the default color for functions. The update function is a special Unity function that is called every frame while your game is running. When a function is called, that means it runs the block of code it contains, which for this case is just line 23. But it is denoted by these curly braces on line 22 being the start of the block of code, and line 24 being the end of the block of code. So every frame of your game, if there's a projectile on screen, each individual projectile is having this update function run, which means the game goes line by line through it. So we go to line 23, since it's the only line in the code, and then what happens is, that line itself is another function call. It's not a function, but a function call. What happens here is that your game now moves to be within this new function call to run the code that this new function, moveProjectile, has inside it. So it's actually jumping down to line 36 and then line 37 and completing that moveProjectile function before it comes back to this update, and then the block of code ends for update, and then it doesn't happen again until the next frame when update is called next. So when you think about running code, you can think about it as a series of walks and teleports where a function gets called, so the function gets walked through line by line unless another function call happens, at which point the execution teleports to the start of that called function, and then that function gets walked through and can call other functions to teleport to, but when a function finishes, you teleport back to wherever the call came from, plus one line below it. So if we walk through update once, we walk into moveProjectile, teleport inside it, do nothing at line 36 because it is a comment, then we do something at line 37, then we hit the end of the function and return nothing, teleport back to line 24, now we are at the end of update and we are done. So if we want to go through and read code for understanding, that is how you can think about it. A series of walks and teleports, and you just have to remember where you teleported from to get a good idea of what your code is doing. The last line I want to point out in this discussion is line 36. This is a comment, a one-line comment. If you read through the scripts we provide, you will see these around in some places to try and provide additional explanation about what is happening in the code. So I hope this video makes code slightly less terrifying if you are new to code, and if you are already familiar, I hope it prepares you for the style of code you will see in the scripts we provide. Later, we will get into more details about functions, variables, classes, and types, until eventually we have you comfortably writing your own scripts.